Hi everybody, welcome to My Physical World. This episode on My Physical World is about the atmosphere. We're going to be talking about the different layers of the atmosphere. We're going to be talking about the components of the atmosphere. We're going to be talking about what it does for us in terms of living on this planet, how it protects us from the nuclear furnace that is 93 million miles away from us. And we will be looking at some animations that I created to try to show how some of these processes work. So, thanks for coming, and let's go to the classroom. Vital to life on this planet is an envelope of air surrounding it and held in by gravity. This is called the atmosphere. The atmosphere provides the much needed oxygen we breathe. It also protects us from the harmful effects of the sun and space. The atmosphere can both contain resources such as oxygen and rain and hazards such as violent weather and pollution. Weather is atmospheric conditions at any given moment. Climate is the average weather conditions over a period of time, and it's usually a minimum of 25 years. There are 5 components of the atmosphere: radiation and temperature. Radiation is usually from the sun, or it could be from the earth itself. Winds and pressure. Pressure basically is the weight of the atmosphere. Moisture and precipitation. Pollution. And air mass movement. An air mass is an organized collection of like conditions of temperature, moisture, and pressure. In terms of the atmosphere, we need to understand the states of matter. Gases, which do not have a definite shape or volume, and they expand easily and rapidly. Liquids, who have a definite volume but not a definite shape. They flow freely in response to unbalanced forces. And finally, solids. They have a definite volume and a definite shape. They are capable of withstanding large unbalanced forces. Matter can change from one state to another under various conditions. The change from a gas to a liquid is called condensation. Latent heat of condensation is the energy released during this process, which is the same during evaporation, about 600 calories per gram. It sounds strange, but a solid can change to a gas without going through the liquid state, and vice versa, such as a gas to a solid. This is called sublimation. Frost in the morning is an example of this, or the evaporation of snow. When a solid goes to liquid, then to gas, such as ice to water to vapor, this is called ablation. As one state changes to another, there is heat energy. There are 2 kinds of heat. Latent heat, which is the heat absorbed and held in storage in a gas or a liquid through the process of evaporation or melting. And then there's sensible heat. This is heat that can be measured with a thermometer. It's heat we feel. Water is one of, if not the most important substance in the atmosphere. Its presence or absence dictates much of the conditions on the Earth. Let's look at how water is present in the atmosphere by examining its 3 states. Water vapor, its gas state, is a combination of nitrogen and hydrogen. Rain droplets are an example of water in its liquid state in the atmosphere. Ice crystals and snow are example of its solid state. Let's take a look at some of the characteristics of the atmosphere. The overall envelope stretches out to about 6,000 miles. However, 97% of its total density is between sea level and 18 miles. The weight of a 1-inch column of the atmosphere weighs 14.7 pounds, or 1,034 grams. This is known as atmospheric pressure, and stated at sea level as 14.7 pounds per square inch, or 1,034 grams per square centimeter. Atmospheric pressure is measured with a barometer. The atmosphere is made up of all states of matter. In gases, 78% is nitrogen, 21% oxygen, 0.93% is argon, and 0.03% is carbon dioxide. Now, there's also traces of ozone, hydrogen, neon, xenon, methane, nitrous oxide, krypton, and helium. Water vapor in the atmosphere accounts for anywhere between 0.02% and 4% depending on temperature. The warmer the air, the more moisture in it. The gases in the atmosphere are important for different reasons. For example, nitrogen is important for plant growth, oxygen for breathing and cooking food. Carbon dioxide is important for photosynthesis. Ozone, found in the stratosphere, is vital for the absorption of ultraviolet radiation. The liquid state is found in the atmosphere in the form of clouds, which are microscopic water droplets. Mists and fogs are also clouds. Solids can be found as dust, soils, and pollens. You can ask, what good is dust and soils in the atmosphere? Well, if it wasn't for them, there would be no rain or snow. They become what is called condensation nuclei. That's what water vapor condenses onto. It's kind of like water droplets clinging to an ice-filled glass in the summer. The Earth's atmosphere is layered. We know this based on temperature characteristics. From ground level to 9 miles, we are in the troposphere. Almost all of life's activities take place here. That's why we call it the layer of life. All of the air we breathe is here. This is the layer in which weather is contained. The highest concentrations of water and dust particles are found here. Temperatures range from 136 degrees Fahrenheit in desert regions to negative 60 degrees Fahrenheit at its top. These temperatures decrease at a nearly uniform rate, 3.5 degrees Fahrenheit per 1,000 feet. This is called the environmental lapse rate. As we reach the top of the troposphere, temperatures remain constant for a while. This is the tropopause. Then they begin to rise as we move higher. We have now entered the stratosphere. It is at altitude 9 miles to 35 miles. Temperatures will rise to about 32 degrees at its top. The stratosphere is where ozone is accumulated, which absorbs harmful ultraviolet radiation. Again, temperature stabilizes, marking the stratopause. As we enter the Mesosphere, which is 35 miles in altitude, temperatures begin to decrease toward negative 120 degrees Fahrenheit at its top, which is 50 miles. As you probably guessed it, temperature levels off for a spell in the mesopause. Then, as we enter the thermosphere, temperatures begin to dramatically increase to upwards of 2,000 degrees Fahrenheit. The thermosphere can also be divided into sublayers, such as the magnetosphere and the magnetosheath. This layer is a warrior layer. That is Earth's first line of defense against harmful shortwave radiation from the sun and space. The Van Allen radiation belt is within the troposphere. The Van Allen radiation belt is a zone of charged particles from the solar wind and held in check by Earth's magnetic field. Solar wind is protons and electrons of energy thrown from the sun toward the Earth. The thermosphere is shaped by the solar wind, which means it is about at the altitude of 50 miles facing the sun and at 6,000 miles at opposition of the sun, or in other words, in the Earth's shadow. As a basic understanding, the Earth has a metallic core about half the diameter of the Earth itself. This core radiates lines of magnetism outward from the south and inward at the north. When we say south and north in terms of magnetism, we are not talking about the South Pole and the North Pole of the Earth itself, which are terms used for the Earth's rotational axis. When talking magnetism, the Earth's core has its own, so to speak, North and South Pole, but they are slightly offset from the rotational axis of the Earth and changes over long periods of time. So, the atmosphere has a lot going on, and key elements dictate the atmospheric environment, such as solar energy. How is the sun acting? Are we getting bombarded by a lot of solar action? You can also check this kind of information out at like spaceweather.com. Temperature elements of the atmosphere constantly change. Precipitation elements and pressure elements. Temperature of the atmosphere is important to life, obviously, and many things can control temperature. Latitude, your position north or south of the equator. As you move poleward, temperatures decrease. Differential heating, land warms and cools rapidly. Water warms and cools slowly. So if you live in a landlocked area, your temperatures will fluctuate more rapidly. As if you lived near a warm water, your temperatures would be more moderate. Ocean currents, such as the Gulf Stream along the United States. Is it a warm current? Is it a cold current? And what is the direction flow of that current? Those ocean currents will dictate your atmospheric temperatures. Altitude also dictates your atmospheric temperature. We talked earlier about the environmental lapse rate of 3.5 degrees per 1,000 feet. If you live in higher altitudes, your atmospheric temperatures will be lower. Landform barriers. Do you have a lot of mountains around your area? Mountains control atmospheric temperature. Low-lying valleys control your atmospheric temperature. And humans also can affect or control atmospheric. Well, I hope you enjoyed your time in the classroom today. We talked about a lot of stuff. We talked about matter, the 3 states of matter. We talked about that type of matter that is in the atmosphere. We talked about water, extremely important on this planet. We talked about its 3 states and how it plays a part in the atmosphere. We talked about those layers of the atmosphere and the characteristics of each one, what each one is important for. We talked about parts of the atmosphere that protect us from the harmful rays of the sun, those shortwave radiation elements that come from the sun. So, understanding the atmosphere is important going forward in our studies. We will be getting into more precise discussion on weather and climate. So understanding those components in the atmosphere is very important. Next episode, we're going to be talking about that radiation balance, on how that sun of ours provides energy to the earth and how the earth reacts to that energy and how that is important for sustaining life on this planet. One thing to note about today's class, you saw the animation of the earth and how the layers are on the earth. You notice that that was a flat earth. The earth is not flat. That was just a chunk of the earth so you can see the different layers of the atmosphere. Anyway, thanks for joining, and we'll see you on the next episode of My Physical World.